Hello everyone. Today we are going to implement the RAG pipeline using Langchain and Google Gemini model. So for this tutorial you need to install Langchain library, Langchain community library and Langchain Google Gemini API access unit. So for that you need to install this Langchain Google Gemini library, and to create vector store you can use this FAISS CPU library. After installing these libraries you need to import the necessary libraries here. So here we are importing the chat Google generative AI for accessing the LLM, chat generate for Google generative AI embeddings for creating the embeddings, and FAISS for vector stores. And to load the text file we are using this text loader function, and to split the text into manageable chunks we are using this character text splitter. Then we are using this chains called retrieval QNS chain to create rag chain, and from langchain.prompts we are importing the prompt template to create our rag prompt. To use this notebook you need to download the Google API key, and using this link provided here you can download the API key. So after that you can copy paste the API key here after running this cell. Now after that you can set the LLM and the embedding models. Here we are setting the Gemini 2 Flash experimental model and other parameters. These details you can find in the uh, Google Gemini documentation and or Langchain documentation. And we are selecting the embedding models here, which is nothing but a text embedding model from Google called text embedding 004. So after setting up this, now we need to load and pre-process the document. So we are loading the text file, which is a text file about retrieval augmented generation. And here I have uploaded the file called ragreport.txt. You can copy the path from here and paste the path to this text loader function. Then you call the loader.load function and load the documents. You can see it has loaded the documents here. After that you can split the text into manageable chunks using character text splitter function. We are using the chunk size as 500 and chunk overlap between two uh, conse- uh, consecutive chunks as 50, and separator is nothing but the new line character which will determine the separator between two chunks. Then creating the chunks is easy using this text splitter dot split documents. Where we are passing the documents it will create the chunks for us. Then we can pass these chunks and the embedding model to this files from documents function, and it will create the vector store for us. What it will do is that it will pass these chunks of the documents to the embedding model and create the embeddings and save it to a local vector store. Then we can create a retriever called vector store as retriever. After that you can create the rag pipeline. So for this we need a prompt template. Here input variable is context and the question, which is nothing but the question provided by the user, and the context is the retrieved documents based on the user query. So in the prompt we are mentioning that use the following context to answer the question, where we are passing the context or the retrieved documents and the question from the user, so the LLM can generate the final answer. So now you can create the QNS chain using retrieval QA from chain type function, where we're passing the LLM and the retriever is created. And here we are setting return source document equal to true. So it will return the source documents which is being used to answer the query. And chain type keywords, here we are passing the prompt template. Then you can query the rack system using simply passing a query, where here we are asking a question, what is the use case of rack. So this is an information which is available in the document. So now you can pass this query to this Q&A chain and we can display the result. Here you can see that it has answered based on the provided context, and it has given us the several use cases based on the documents, and it has correctly retrieve the source documents. Here you can see It has correctly detected the use cases of RAG from the documents uh, provided. So this was all about it, implementing a simple RAG pipeline using Langchain and Google Gemini models. Thank you.